Hi, I'm Mark Wilson, the Engineering Heretic, and today we're going to look at, I've had a few issues with my little D-bit grinder, and as I said before, I replaced the bottom bush area on this area here, which makes the radius swing on this particular head here. Now, because the bush area I had to replace on the bottom area down here, then I can no longer really rely that these original lines here for setting the radius is correct. And of course I did try it, and on the 0 point there, this machine should cut a full ball nose cutter, but it doesn't. So it's a little bit out of position. So what I've done is I've removed the rivets on these ones here, that one there and that one there. I've slotted the holes on this, and I put in screws. And of course I put this back in what I believe to be the same spot it was before on the 0. So that's lined up as best I possibly can. So that's the theoretical point, which I know is incorrect. And that's going to, so now what I can do now is I can move, once I get this in the right position, what I can do is undo these screws here and then move this around here, and I'll use a magnifying glass to get this exactly right. Now, a lot of these machines come with a vernier scale on this one here. There's a vernier scale on this. This particular machine does not have a vernier scale. So I'm just going to have to rely on just the graduation. They're in millimeters. I'm just going to have to rely on estimating probably the half and the quarter millimeters on that. I've been estimating tenths on imperial micrometers and microns on metric micrometers on graduations similar to this for the most part of about 50 years. So I really think that a vernier scale, although it would be nice and a little bit more definitive, that I can easily with a magnifying glass get this to within about 0.1 of a millimeter, about 1/4 thou. If it's halfway, you can estimate halfway pretty easily. You just side up so that they're dead even between the 0 line here, and that will be close enough. If it was a half of that again, like a quarter, I reckon you could get that. And I reckon if you could basically divide up one of these millimeters into basically in your own little, just by eye, into 10, I reckon you get this down to around about 0.1 without a vernier scale. So I'm just going to rely on this here. Quite often these particular machines only go in one direction. There's only a scale going in one direction, but this particular machine here has it going in both directions. But that's neither here nor there. You really only use it one way anyway, but they've got the full scale here. We'll just stick with what we've got. So let's put this back on the machine. I've got this on the bench at the moment because I drilled and tapped these out, removed the rivets on this one here, and put in these M2.5mm screws and slotted the hole so I can move this top plate here at will. Rightio, so on the machine now, I'll put this head back on, and what we need to do is find or establish a known. Okay, we've got this scale here reading off in millimeters. I have a 6mm, quarter, 6.35 cutter in there. So what I need to do is get this set on something that I believe or establish a known. So what I'm going to do, I'm not going to make a D-bit, I'm just going to make it round, because you can make a perfectly round cutter and just spin the whole thing. It's not really, and then swing it as you're spinning it and make a full radius on the front of that, just exactly like a D-bit, but except you don't have to do the split and the clearances and what have you. It'll be much easier to measure anyway. But I need to establish this known size, or a 0 size. Now at the moment I've got this scale set on 0, so I should cut a full ball nose on a 6.35 or quarter. What I'm going to do is I'm going to grind this front section down here to 4mm there, I'm going to offset that by 2 millimeters, which is the, if I put that offset by 2 millimeters, it should theoretically cut no radius at all, a 0 radius on the outer edge, because that's the, normally if you were doing, say, a 1 mil radius, you'd offset, if it was 4 mil, you'd offset that by 1, which is half the diameter, and then we'll cut a 1 mil radius on the outside. So if I offset this by 2 mil at 4 mil diameter, theoretically it should not cut a radius at all. It should be dead sharp. So we're going to, well, first of all, we'll establish that 4 mil diameter, and then we're going to do this swing around here and see if we can get this cutting a 0 radius at 4 mil diameter. Now, first of all, I'm going to adjust a little side, the windage over here. We're going in that direction there, 2 millimeters exactly. So I'm going to do the little side lock here. I'm going to move this over 2 mil exactly. And because we're trying to get this as accurate as we can, I'm going to use a magnifying glass for this. So according to that is correct at exactly 2 millimeters. Right, so I've got that set. So now we need to make that 4 mil diameter, and we're going to have to play around with this to get this right. Rightio, that's exactly 4 millimeters. So now what I need to do is get this set in the length here. I'll do that by swinging this around 180 degrees, or so 90 degrees, and grinding the front face. Slide that in, make contact. So now I've got my distance set in that direction. If I unlock this here, swing this around here, should cut no radius at all at that point. And of course it's cutting ever so slightly, making a tiny little radius. So that should not be grinding on that at all. It's actually cut a radius. So clearly I need to come over just a fraction more in that direction to make up for that. So what we'll do is we'll go over a little bit. And we'll do this again. Grind the front face. That should not cut a radius there at all. I don't believe that has. We'll just go in a little bit further. Try that again. Right, I believe that is not cutting a radius at all. I'll just go a little bit further over and just see if that, I'll check and make sure we make it get a cut a slight radius. Just cutting there. I believe that's the tiniest of radiuses, so we're going to move that back just a fraction more. try this again. I believe that's quite sharp. So now what I can do is I can adjust my little zero, because I can undo those screws here, and I can move the zero around to make that zero. So now we've established the known. We'll set that exactly on 2 millimeters. That way, anytime when I have that back on zero, it will cut a full ball nose radius. So let's just adjust that now. Okay, now we're going to put this back onto zero, and we'll see if this now cuts a full 2 mil radius on a 4 mil diameter. So we're going to slide that back to zero, and I'll get that as close as I can with a magnifying glass. And that should cut a full ball nose. And that, I believe, confirms my diagnosis that now that when that's exactly on zero, that will cut the correct radius. And that is how I believe you set this particular thing here. I've had to do it because this particular bearing was incorrect in the first place. Now I've fixed that up and it's made that little bit out. And that's how I've adjusted this and got that correct. And I'm Mark Wilson, and thanks for watching.